Topic 2 is going to be on Radian Measure. So far, we have used degrees as the units of measure, but it's really a very arbitrary measurement system. How big is 1 degree? Could you draw an angle that had 1 degree? Why are there 360 degrees in a circle? It's really quite arbitrary. So we're going to work with a new way of measuring angles that is not arbitrary. So imagine a distance and an arc length of exactly 1 unit along the unit circle. This arc length is exactly the same thing as the radius. Okay, so looking at this little picture here, if I have an arc length that is 1, the same as the radius, this is going to be the precise angle that we now refer to as 1 radian. We are measuring radians in terms of arc length. The arc length is going to be the radius. Is going to be the radian measure. Sorry, radian radius sounds similar. So everything that we actually did before when we were measuring distances around the circle, those are going to be our angles in radian measure. The distance around the edge of a circle is its radian measure. So how many radians are there in 1 full circle? It's the circumference. It's the length all the way around that circle. So there are 2 pi radians in 360 degrees. Ooh, we mentioned that on the top of this page as well, talking about 1 revolution being 2 pi is a distance. That 2 pi now is our radian measure. So we have 2 ways to refer to angles in the distance around and the old degree measure, which is going to become obsolete. Radian measure is a much more useful way to measure something because it's talking about the circumference or distance around that circle. Okay? Now, technically, it doesn't matter how long this circle is, the angle stays the same, but we define radians in terms of a unit circle, a circle with a unit of 1. So actually, based on the definition, the circle could be shorter and we're still going to have the same radian measure. So the definition does deviate away from distance as we allow that distance to become arbitrary since the trigonometric ratios are going to be consistent. But that's where the definition of radians comes from. Okay, so 1 degree is that little bitty arbitrary measure right here, so tiny, and then 1 radian corresponds to an arc length of exactly 1 as the measure, 1 unit of measure. Okay, 1 radian is approximately 57 degrees if we were to convert them. It's just the pi ratio of that. Okay, so there is a link here at the bottom for some examples that might help us visualize the concept, so please take a look at that. I'm going to flip on to my next page here about converting between degree and radian measure. So instead of using the 360 degrees every time being 2 pi, that ratio can be simplified. I know that all the way around the circle is 360 degrees. That's the same thing as 2 pi radians. We can simplify that to the ratio 180 degrees to pi radians. Just if you divide them both by 2, you get this simplified ratio. So halfway around the circle is 180 degrees, half around the circle is pi radians. We use that for conversion. So we would convert by knowing that 180 degrees is equal to pi radians. So if I want to convert, depending on what I already have, just using a unit conversion fraction of either 180 over pi or pi over 180 radians. Now, when you write degrees, you have to use the degree symbol. Radians, however, are unitless. If you just write something like pi, or if you just write an angle like 1, it's assumed to be in radians, and they are unitless. So theta equals 1, that is not 1 degree. If I don't write the degree symbol, then the angle is assumed to be in radians. We are going to be especially careful to make sure that we include degree symbols when we mean to be in degrees, and to use no symbol for radians. Some people like to be extra clear they're talking about radians, so they could put 1 RAD if they wanted to, just to make extra clear, but it is universally understood if you write no unit after it that you're talking about radians. So to convert for degrees of radians, radians degrees, we're going to multiply one of our unit fractions. All right. that note I was mentioning down here, any angle, like I said, without units, any angle without units is assumed, like I said, to be in radians. Great. Okay, so let's check out the rest of these. We're going to do some conversions. I'm going to grab probably a calculator for this. I've got 135 degrees, and if I want to convert this into radians, we're going to take 135 degrees times that unit fraction that has 180 degrees in the bottom, so the units cancel, and pi radians across the top. So the units, degrees, and degrees cancel, and I just need to get this as a reduced fraction. So instead of typing 135 times pi over 180, I'm going to not type the pi. I'm just going to type in 135 divided by 180, make it into a fraction, and then it's 3/4 pi, or 3 pi over 4. I don't want to type in pi, or I get this big decimal with pi expanded. I just want this as a reduced fraction in terms of pi. So that is the angle of 3 pi fourths. Again, just making 135 divided by 80 into a fraction. If I did that again on decimals just to see how it would look, I can, oops, I don't have decimals open, hold on. Okay, now it's launching. Therefore, I can type in 135 divided by the 180 again, converting it back into a fraction with the fraction button here. If I type the pi with it, it's giving me the nasty decimal. Don't want that, so don't type the pi, just write the pi in after you've got the fraction simplified. So there we go, 3 pi over 4 for that radian measure. Okay, now I've got negative 30 degrees, something similar. So we're going to write this as negative 30 degrees. Need the 180 degrees in the bottom to get the units to cancel, pi radians across the top. Again, that cancels out the degree measure, and I'm going to not type the pi. I'm just going to type in the negative 30 divided by the 180, giving me negative 1/6. So negative 1/6 pi, or negative pi over 6 is how we would commonly write that, negative pi over 6. And I'll flip back to my screen. There we go, negative pi over 6. Okay, so those were in degrees because I have the degree symbol. These don't have a symbol, so they're assumed to be in radians. So I'm going to convert them into degrees. So negative 3 pi over 4 times, now this is the reverse. It's already in radians, so I'm going to divide by pi, radians, and multiply by 180 degrees. I leave these things in terms of pi so that the pi's cancel, and then I can multiply negative 3/4 by 180. So that should give me, let's find out, negative 3/4 times 180 gives us negative 135 degrees. All right, then on to the next one. We've got pi ninths. So again, same process, taking pi ninths times 180 degrees over pi. That gets the pi's to cancel. And then I have 180 divided by 9. That should go in evenly and give me 20 degrees. Okay. The bottom two, negative 6 pi. Okay, so negative 6 pi is also in radians. So I'm going to multiply this by 180 degrees over pi radians. The pi's cancel again, and I have to do negative 6 times 180. I'm not sure what that comes out as. Let's find out. Wrong button. There we go. So I need a negative 6 times a 180 comes out with negative 1080 degrees. Now this is of course many times around the circle. If I was to draw an angle of negative 6 pi, I would go negative 1, 2, 3, 4, 5, 6. So I'd be back on the x-axis right here, negative 6 pi. So negative 1080 degrees is the same angle, and they're also coterminal with the angle 0. This is a it's not the same as the angle 0, it's coterminal with it, meaning I spun around a few times to get there, but I landed in the same place. Oh, darn it, I forgot to put my screen back. I drew a nice circle while my screen wasn't looking, but it's just going around a few times to get there. Sorry, I need to watch my screen. Okay, let's get to the end of this page right here. We have another angle 25, and I need to convert this into the other measure. Notice that there is not a degree symbol on that 25, and so we are going to assume it is in radians, and we're going to multiply it by 180 degrees over pi radians. Because there is no pi to cancel this time, in degrees, I will divide out the pi. So I will go back to my calculator, and I will take 25 times 180 divided by pi. We want our radian measures in terms of pi where possible, our degree measures not so much. So we are going to convert this into about 1,432.39 degrees. All right. And that would be an angle now in degree measure. Now I can put the degree symbol on it. All right, taking a look here at these two pictures in the bottom, we have just a few different angles that are listed on the unit circle in both degree and radian measure. So for example, 30 degrees is pi sixth in radian measure. We'll talk about how to find those as we get into the next section as well. So I have 45 degrees, that's pi fourths in radian measure. 60 degrees, that's pi thirds in radian measure. 90 degrees up here on the axis, that's pi halves in measure, etc. Now, this first graph is just for the positive angles. There are only a few angles drawn here, not all of them, because of course you can use reference angles from the first quadrant to get in around to the rest of the quadrants and so on. The second graph here is the same graph, it's just for the negative angles. You don't really need both graphs because you could just take this graph and flip them down here into the negatives and continue that way as well. But again, if positive 30 is pi sixth, then of course negative 30 is going to be negative pi sixths. So just watching out for these. These are just the same angles, they're just in opposite rotation, rotating down from the x-axis instead of up from the x-axis. Note at the bottom right here, we must memorize reference angles in radians and degrees. So those charts that we have memorized in degrees, we are going to have to memorize in radians as well. We're going to need to be able to convert back and forth between them. We're going to need to know what the common ones are. The common degree angles were 30, 60, 90, 45. They're going to be pi 6, pi 4, pi thirds, pi halves in radian measure, and we have to know those.